Robots start each match on one of their tarmacs.
During the first 15 seconds of the match, robots are autonomous.
Alliances earn additional rewards for meeting specific scoring thresholds and for cooperating with their opponents.
It's this presentation that provides each team with all the information it needs to begin the task of building a competition robot. Now it's up to about 60 students plus teachers and mentors. First, the team will choose a single task as the priority from all of the ones set out in the competition overview. Then it's into design.
We look at how we can manipulate the game piece, capture it, control it, pick it up off the ground, or depending on if you have to pick it up from a station. And off of there, we make different prototypes on just how the game piece is going to be manipulated.
As the design comes together, blueprints are shared with the manufacturing team, who produce almost 100% of the parts. All of the conventional tools are available, but so is automation in the form of CNC machines.
We manufacture everything from like tubes to plates and basically manufacture most of the robot. And then for conventional, we have things like lathe, bending, plasma cutter. Plasma cutter makes bigger pieces faster and quicker than CNC can. And it's more for like rough cuts, I guess. And then for lathe, we make like axles and head shafts and things like that, the smaller components that go on the robot.
Next, it's time for the team who describe themselves as the ones who make the internal organs of the robot, because without the electrical team, it's just a statue. While wiring and working with the drive motors are a core part of their responsibilities, so is staying up to date with the latest technological advancements.
With our sub-team, we change so much because of the electrical, the components update every couple of years, and so we have to relearn everything.
Constantly changing technology is something the programming team must also be attentive to. Using multiple programming languages, they'll write thousands of lines of code, which the team say is roughly equivalent to second or third year university work. All of it will allow the robot to move, enable it to pick up game pieces, and deliver them to the scoring area. Success on competition day also hinges on making the robot as autonomous as possible.
So you're trying to take the load off the drivers, trying to pretty much do everything on the computer and process it so that the drivers have more time to do everything else.
Hi, welcome to our channel. I'm Liam.
And I'm Shannon, and today we'll be giving you a tour of our 5409 robotics program.
The media and business teams are also integral to the success of the robotics program. They'll create and share content on social media for various audiences. When they're not in one of the team areas, an on-site television studio, complete with green screen, is at their disposal.
All of the robot in action videos are our most viewed videos because everyone wants to see what a robot can do, especially the reveal video that comes out around March every year. It's mostly for the FRC teams to see what our robot can do and what we've done to make our robot a competitor in the games.
Among the audiences they serve are current and potential sponsors. One of the teachers involved in the program shared that it takes between $25,000 and $35,000 to build the robot each year, and roughly $130,000 a year for team operations, including traveling to competition. Sponsors fund about half of that total.
This is what the students have been working towards: 3 days and roughly 20 hours a week, including weekends. A competition-ready robot. But just before those begin, one final check to work any kinks out of the software. In part 2 of this behind-the-scenes look at robotics, we'll take a look at those competitions, as well as talking about how this experience is shaping their futures. Jason Trout for Halton News in Oakville.